Juno is NASA's latest mission to a planet in our solar system, and it's going to go to Jupiter. And Juno is an incredibly ambitious project. It's a spacecraft that is powered by solar panels. It's going to go incredibly close to Jupiter, and importantly, crucially, is going to go into something called a polar orbit around Jupiter. So it's going to fly very close to Jupiter, over the poles, and will go closer than any spacecraft has ever gone before, and that will enable that mission to collect data which is way beyond anything that we've previously done.
The objectives of the Juno mission are threefold. There is a study of the internal structure of the planet, how the mass is distributed on the inside, whether there is a solid core or not. Secondly, there is an objective to look deep within the atmosphere of the planet, above the visible cloud tops that you can see from Earth, to understand the structure of the weather layers beneath the cloud tops, the origin of the Great Red Spot and so forth. And thirdly, there is the objective of looking at the origins of the planet's auroras, which are the most intense auroras in the solar system. The Earth, of course, has auroras around the pole, so does Saturn, and so does Jupiter, but Jupiter is by far the most powerful. And we want to know the origin, the physical origin that drives the auroras, and the connection with the magnetic field at large distances.
The University of Leicester's involvement in the mission is through Professor Stan Cowley, who is a science co-investigator on the main Juno science team.
And that was because we had been involved in theoretical studies of Jupiter's environment in the immediate couple of years beforehand, and had produced a research paper that was published in 2001, which has become the definitive model of how Jupiter's auroras, or how we think Jupiter's auroras, are actually generated. And so when this mission was being proposed to NASA, we were the go-to people to be involved in the planning of the mission. And also when the spacecraft actually gets to Jupiter, we are going to be involved in the data analysis and the interpretation of the data that the spacecraft sends back.
So obviously this is the first opportunity that we will have to test out our theoretical ideas and also use the magnetic field data from the Juno mission to actually measure magnetic field perturbations as the spacecraft flies over the auroral regions, which will allow us to understand whether or not our theories are correct and what actually drives and changes Jupiter's aurora over time. If we want to understand the solar system and how it formed, how it evolved over time, then we need to understand Jupiter. We understand quite a lot about Jupiter, but we don't know the details of the interior, whether or not it has a core, how much water is contained in the atmosphere. So the details are really, really important. And due to Juno's unique polar orbit, we really have an opportunity for a step change in our knowledge. It is a game changer. The results that will come from the Juno mission will significantly enhance our knowledge of Jupiter overall.